Hello everyone and welcome to the video part 1 on infinite series and induction.
And I know this isn't my usual intro, but I couldn't help but share. There's ducks in our pond! I just think that's cool. Yeah, that's it. I just wanted to share that with you. So, enjoy this video. There they go.
For starters, you should know we're still going to be looking at a sequence or series and adding up to make a total sum. However, you'll notice that there's no upper-ended bound on this setup. And you might be wondering, how would any setup that goes infinitely ever end? To be fair, a lot of them don't end. They're called divergent. They diverge away from any possible answer. However, there are some that will converge, that as we continue down the sequence, they'll get closer and closer to being an exact value. And in order to handle that, we are going to need a formula. The series sum will be equal to the first value over 1 minus r. The r represents the multiplied ratio of the geometric series, and t1 represents the first value in it. We'll see more on that in a little bit, but please know that sometimes we can check to see if an answer is going to be convergent by testing its limit. Instead of doing the entire sequence, we might just test the first few values and see if it's getting close to something. A limit is when you take a partial sum and see if it approaches a certain value. Now for a couple examples of an infinite series. Our first one is simply a list of decimals, which we will check for a common ratio. At each step of this sequence, we're multiplying by 4/5, which represents our ratio. Our t1 is 5, since 5 represents our first term. So in order to figure out our series answer, we will need this formula from the last slide. If I plug in each value, t1 and r, to this formula, we'll be able to solve the problem. Solving this expression gives us an answer of 25. In our second example, I'm going to first start by writing out the first few steps of the pattern. Well, now that I've noticed that the first term is 2/5 to the first power, or 2/5, and then the second is 4 over 25, and then our third is 8 over 125, I'm pretty sure I can see that t1 is 2/5, and our r is also 2/5. This means when I evaluate the series, I'm going to do 2/5 over 1 minus 2/5. And since that simplifies to 2/5 over 3/5, my answer is 2/3. To sum up our video on infinite series, notice that our goal is to identify the pattern, identify our t1 and r, and use the formula to evaluate a final sum. I hope this video has been helpful. I wish you the best of luck. Stay happy and healthy, and I'll see you in the next one. Bye!